lecture where we'll be going over programming paradigms. So diving specifically into the programming paradigms and what the objectives are for this particular lecture, overall we're going to understand the core concepts of what a programming language is and why we need them. Within that we'll go into key concepts such as like key terms, as well as an overview of the different programming languages, as well as the different frameworks of different programming languages. From there we're going to gain a broad overview of the different ways that programming languages approach instructing computers. And then so within this and throughout this, the goal is kind of to illustrate and to talk about the general concept of how programming languages work. And so starting off here with this particular introduction within the objectives, the very first thing that I can say is that so at a very basic level, machine learning, the way that machines actually like interpret code, or like outside of machine learning itself, but the way that the machines will translate the code is always binary. So if you're unfamiliar with binary, everyone is, it's zeros and ones, right? So that zeros and ones code, no matter what language we're choosing, except for Python, which we'll get into further into other lectures, but every other language outside of that, it's the essential function is that code is getting translated back into binary. The computer is going to read that programming language in binary. The reason why the programming language exists is for you, the human, for us to be able to interpret the programming language better. The computer would prefer it all in just zeros and ones. And then so that's kind of the advancement of programming languages and why they exist overall. And that's a key concept overall, is that all of these individual programming languages that exist, they don't exist for the computer. The computer's always going to trace it back to that individual binary language, like the fundamental language of computers. If my native language is English, the native language of every computer is binary. Like every single one, it knows binary, and it's going to translate it back into binary. And then from there, we're going to start developing the vocabulary to talk about programming concepts with more precision. And then so the goal here overall is that by the end of this lecture, you'll understand programming and the theories of programming just a little bit better, and to be more precise with your both descriptions and understanding of these concepts. So with that being said, let's dive into lesson 1, which is what exactly is a programming language. And then so the very first thing to keep in mind here is that computers aren't clever. Computers, they don't understand natural languages like English. They require specific instructions to operate. Again, just highlighting and going back to this concept because it's very important. The computer is always going to translate back into binary, into zeros and ones, is its basic fundamental understanding. And so any sort of logical function, anything that you introduce to the computer, it has to be defined, and it has to have defined and or a function associated with it. And we'll get more into what functions are, and we'll talk a lot about functions throughout this course. But so starting off with that precision, the very first concept that I want to introduce you to is functions. And then so a function is just very simply, in simple terms, getting the computer to do something, like a repeatable action. Is a good way to look at a function. And several different languages utilize functions in different ways, but functions are a concept that are universal across languages. And then so when I'm talking about methodology specifically within this particular lecture and overall, what I'm trying to introduce you to is concepts and vocabulary that is universal across programming languages. That's not specific to one individual programming language. So, and then diving into the next concept is that translators for machines. So programming languages are specialized languages, and they're designed, again, to communicate with computers. That's the end goal, right? Is that the programming languages are the UI for the end user. And within that, then, like, why aren't they simpler, right? Because again, like, you do, like, it always has to get back to those zeros and ones, those binary functions. And then within that, again, you're explaining everything that possibly exists to the computer in order to do those functions. So when you deal with libraries, which is another common term that you'll deal with and utilize across different programming languages, libraries are essentially groups of functions, which we talked about earlier, and other types of code in general that are bundled together that do specific actions and repeatable actions. And so you would utilize library to make things very simple or simplistic, or to load in kind of like everyday functions that you would need to do, or to expand your ability to of your application and just use essentially like the generic code of the library. That's kind of the overall concept of how libraries exist and why libraries exist there. And then so diving into this more specifically, this is a coding course, so I want to expose you to code overall as much as possible, right? And then so starting off, this is our very first exposure to code, and this is simply Hello World. And I'm showing you Hello World in two different programming languages, and the two languages that I choose are very specific, right? So the very first one is Python, and then the second one is HTML. And then in Python, it's very simple and straightforward. Print hello world. That's literally this, and you one line of code and you'll get your hello world app, and it'll hello world. That's what it's going to say. HTML, a lot more, right? There's, because of the fact that there's not libraries necessarily built into HTML in the same way as Python, and it doesn't utilize libraries in the same way that Python does. You have to build out every single aspect of this, especially within HTML, right? So you're telling it exactly what type of document it is, what the header is, what the title is, what's in the body, what the message is, and then like here's the end of the body, and then here's the end of like all of our HTML, and you have to explain all of that just to get hello world. And then so one line compared to 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11 lines of code, right? So very big difference just depending on the different programming language, but both of these are essentially doing the same thing and essentially functioning the same way, although again Python is the overall exception to all of this, and I want to point that out overall again and again. So when I talk about like code always being translating back to binary and zeros and ones and all of that, that's true for every single programming language in existence except for Python. and just introducing it and getting that a little bit further. So all programming languages, again, they're built off of that concept of reverting it back to that binary code, right? So all programming languages, they're built with this concept of machine readability and learnability first. Whereas Python is like the one exception to that lane, where it's let's put human readability and usability first, and then secondarily worry about the computer readability and functionality. And that's essentially how Python works overall. Like you'll see a lot of descriptions of Python where they'll treat it like it's like a sidestepping language, or there's unique aspects to Python, and that's the unique aspect, right? That it doesn't translate back to binary. It's got its own translator built into the language, and then so very specifically what that means is it's more specifically built, it's very specifically built for you as a human. And then so if you're trying to understand and learn and get into programming, Python is like you're welcome, right? Because it's just a lot easier overall to understand than a language, especially like HTML, or an older language, especially like C++ would be like another example comparison there. Like a lot of those are the kind of the big two that people decide on. Like, should I go C++ or should I go Python? I'd say overall, Python is much more beginner friendly, and it's more like you can do more in C++ overall than you can in Python if you understand C++, but that is also adds to the complexity overall of C++. Like C++ is a lot older of a programming language, so like 90% of the libraries that exist within C++, you don't utilize anymore, right? and so it's there's like newer libraries, and so that's a lot of the complexity of C++ is like knowing like, oh, there's like these 15 outdated libraries, but you should use this one newer library that does the function. And so just giving you kind of overall there. But so diving specifically into key terms and starting here, again, these key terms are designed to be generalizable across programming languages. So no matter what the programming language is, all programming languages will, including Python, will utilize essentially these terms. And then so starting off with variables. Variables are named containers for storing data. So a named container could be a number, it could be text, or it could be something far more complex than that, like a database or tables within databases, etc. So tables can be, or variables can be complex objects, or simple objects, or simple just numbers and text. And then from there you have data types, and then data types are essentially your classification of data. And then there's different data types, and you should be generally overall familiar with these, I assume. So you have integers, which are whole numbers, floats, which are numbers with decimal points. So difference between an integer and a float would be, integer would be like 1, 2, 3, 4, 5. Floats would be 1.5, 2.5, 3.5, 4.5, etc. Strings are just text, and then so strings could be text and numbers, right? So like you could have a text and number string, and then booleans are true false values, and then I think a big one to get into here as well is arrays, and then arrays are utilized differently across different programming languages. So different programming languages will utilize arrays differently, and or not allow arrays in certain instances, things like that. But so I think it's important to highlight that overall, and I don't want to get more into the semantics of arrays, because then you start getting into the semantics of individual programming languages, which is what I want to avoid with this individual lecture. But I do want to introduce you to the concept of arrays that exist overall within this data type structure. And then from there you have operators, which are essentially symbols that perform your actions on data. So arithmetic operators, comparison operators, or logical operators. And then you can get really creative and robust with your operators and different operators, and you can, and for example, combining like arithmetic and logical operators can get you into like really cool things and stuff like that. So just mentioning that overall. And then your control flows, which are like essentially like how exactly you want the code to be executed. So if statements, and then loops, like for loops and while loops. Just like do you want to be like a sequential order, or do you want it to loop all the way around? Do you want how exactly do you want that execution to take place? And different programming languages, they have different rules around that execution, right? Like some programming languages, it doesn't matter the specific order of the execution, it'll execute all at the same time, or some it's very important for the order, etc. And then so just highlighting that control flow will be very important across languages overall. And then last but certainly not least is functions, or some languages will call them procedures. But so they're essentially overall the same thing. They're reusable blocks of code that perform a specific task. They take an input of arguments and they return outputs. And I went over functions earlier, so I think that kind of covers that generally overall. And then so with that, that leads us directly into lesson number 2, which is essentially the 3 programming paradigms that exist. So far we've talked about the key terms and programming languages in this very generalizable term. My next goal with this is to bring it down, like one layer down, right? So the next layer down from programming languages as this nebulous concept of key terms is programming languages as paradigms, and the paradigms that programming languages follow. And then so within that, there's 3 overall programming paradigms that you'll find. And then so within these paradigms, what you'll see is that every single programming language that is in existence, including Python, falls into one of these programming paradigms. And the reason why Python is an exception overall to this is that it falls into multiple of these paradigms. And then there's a few languages that do fall under that same list as well, such as JavaScript, and we'll get into those those languages that are the exception here as we go through on lesson 2. So diving in specifically into why exactly programming is imperative and why it's not going to go away. So very specifically, and what exactly imperative programming is overall as a paradigm. And imperative programming overall is very specifically telling the computer what to do, and it's very specifically a step-by-step approach. It's programming with a series of commands that tell the computer how exactly to change the programming state. So each command results in updates to variables, data structures, and memory. So within imperative programming, you have like your most basic languages, including BASIC, would be included in imperative programming. And then so you, like essentially the analogy overall for this is a recipe. So think of within imperative programming, you build a recipe, right? You have your ingredients, which are your variables, and then you have your cooking instructions, which are your overall commands, and then the finished dish is you combine all of that together and you blend all of it together, and then you get that final state output from that from your variables and your commands, right? And it's those building blocks of variables and commands very specifically. And then so diving specifically into the types of programming languages that fall into imperative programming languages. So as I mentioned, there's BASIC, the most basic language. So BASIC is it was designed as a very early on as a like very user-friendly language, and then so you have BASIC, COBOL, and Pascal, and Fortran, which are like the old ancient languages. And then what I'll say with this overall is, and so some of these languages are still in existence, right? Like for example, in the financial space, they rely heavily on COBOL, and then so if you learn one of these, COBOL, BASIC, less so BASIC, but if you learn even BASIC, so if you learn COBOL, BASIC, Pascal, or Fortran, you can have like a rich and robust career, very specialized career based off of those languages, right? And maintaining systems systems that are older than me that utilize these programming languages. But what I want to highlight with this overall, and I think it's important to highlight within this lecture, specifically when we're talking about and first introducing these older languages, is that, so to me, when we're talking about programming languages overall, like why do we have ancient programming languages compared to newer ones? So the very first thing that I want to point out is that like anything that you can really think of generally as far as an overall concept that a computer can do, like in general terms, was solved in the 1950s, like with BASIC and COBOL, and BASIC, COBOL, Pascal, and Fortran. Like you could write anything, anything that you can think of, and it could be like fuzzy logic, it can be AI. All of it was initially written and solved for in these programming languages, and then so a lot of moving forward has been refinement and improvements on what these programming languages have already solved, making it easier for the end user overall, right? And that's, again, when we're talking about easier overall, we're always talking about easier overall for the end user, which is you. And then so that's another important thing to highlight too, is that so when you generally speaking, when you go back with these languages, so generally speaking, Fortran, Pascal, BASIC, and COBOL are quicker and less computing, far less computing resources than C, C++, and Java, with C being kind of the exception. So C is also an older language, and then so you'll notice there's variations of languages, right? And then so Java is the oldest of the Java languages, and then C is the oldest of the C-based languages. And then so with C-based languages, you have like C, C++, C Sharp, etc. And then with Java, there's Java, JavaScript, JavaFX, and then all different frameworks that are built out off of like Java, like React and React Native, etc. And then so overall, the newer the language, the more it's really designed to be user friendly or to solve those types of user problems overall. Whereas with these older languages, they're like a lot closer to that initial like zeros and ones languages. It's kind of like the big exception, and like what I would say that they're designed to do, and they get like a lot harder as far as understanding the syntax because it gets more and more away from like human readability the older the language goes in general. And then so that brings us to object-oriented languages, or OOPs, which is kind of like building your world with objects. And then so a lot of systems that we utilize today are object-oriented programming systems, and object-oriented databases, very specifically, are like a very common way and feature to code within current programming. So objects are building blocks within this. So think of a program as a collection of objects that interact with each other, and they can be objects can be tables, databases, or like functions overall. Again, so objects are self-contained entities, and objects always contain two things. They contain data, so the attributes, the information that the object holds, as well as the actions, so things to do with the data. And then so that's what makes object-oriented programming very robust overall, right? Is because it's, at the end of the day, it's just combining data with actions, and then you can store the data in different ways, in different tables, etc., and then you can take a multiplicity of different actions, right? And then so when you combine those two things, you can get like a virtually like unlimited things that you can do, and you get essentially like it's two Lego bricks, right? And so your your bricks equal your objects, and then you build those bricks into programs, and then within object-oriented programming overall, like, just like Legos, right? You can build the bricks into anything, and then so object-oriented programming is very flexible overall, as long as you are following that structure of data and actions, and a lot of stuff falls into data and actions. Not everything, right? Which is why computers, and which is why we run into a lot of issues overall, but a lot falls into data and actions. And then so diving into the most popular object-oriented programming languages, you have Java overall, which, again, one of the oldest, and it's like the base. And then JavaScript, which is meant to more compete with Python, like a lot more flexible. And then this is where you have your C derivatives, so C++ as well as C Sharp. And then Ruby is a common programming languages for like a front end, and for like web development overall. But so Ruby is a web-oriented system, but allows you to bring object-oriented programming into web functionality, and it was like kind of the first to do that. JavaScript also allows you that functionality, and you can build into that. And then Python here on the list is, again, as I mentioned earlier, Python covers into multiple of the different types of languages and frameworks, but Python is it fits in here. Like a lot of people utilize Python as an object-oriented programming language, and it's really robust and easy to use overall, and like for that specific functionality. And then last but not least, we have functional programming. So think of it as like essentially like a data transformation pipeline. And then so with functional programming, essentially what this does is it brings functions to the very forefront. Like functions are everything within function programming, right? And so they can be passive arguments, and you can pass functions and return functions. So it's a lot more flexibility as far as what you can do with functions, but also at the same time it puts them at the very forefront, right? And then so within that, data is not directly modifiable, and it's not modified directly by functions. Instead, the functions, they take the data and they produce new outputs, leaving the original data untouched. And then so the functional programming is really common within like enterprise organizations, and especially like dealing with like databases and things like that, where you want to utilize like data science and apply different methodologies to the data and transform the data, but you want that original data to stay the same, right? You're essentially like transforming copies of the data, and then so within this, you can think of it like a pipeline, right? So you have your data, which is like your raw ingredient, and then you have your functions, which are like the processing station, which they like copy the data, and then they take the clone, and then they like manipulate the clone, like they add stuff to it. It's like CRISPR, right? Like so you first you clone it, and then you add CRISPR to it, and CRISPR, like you're changing the DNA of whatever the clone is, and then you have your final output, like Dolly or whatever it is from the CRISPR output, right? And then your finished product, like your final output, it's not it remains like it's like the maternal original object is still there, right? And so that's kind of the overall difference there. And then so diving into functional languages, I'm assuming that overall, like, most of these are going to be languages that you've probably never heard of. If there's one that you've heard of, it's going to be Haskell. And then so Haskell's really, it's a functional language that is designed for mathematics specifically, and then it's like really like it's the most influential language on this list to me. And then you've got a few other ones like so. If you've heard of Haskell, then you might have also heard of Clojure or Elixir, which are two other frameworks, and then they do different things, right? So for Elixir, it's very specifically for like web programming and development, and then you can also see here that you've got Microsoft has their own functional programming language, F Sharp. So again, like a lot of these. And so, like, if you want to get like really, if you want to have like real good career security and stability, focus on one of these like these smaller languages, right? Like F Sharp or Elm or COBOL or like a language like that, and you'll have a job security and a career just based off of understanding and doing these languages that like not a lot of people will go for, very specialized languages. So overall, my recommendation and with this course, of course, is to go broad, right? But if you do find yourself and you want to focus on a language, my recommendation wouldn't be to focus on like Python or something like that. I'd focus on like COBOL or like very, very niche, right? And then you're not going to have a fun career that way, but you'll have like huge longevity out of your career. But so overall, this is summing up our lecture on programming paradigms. And then so in future lectures, we're going to be diving into more concepts and more of the theory related to coding and overall concepts. So I look forward to seeing you in future lectures and future courses. Thank you very much.